Okay, welcome. Today we're going to talk about surface area for three-dimensional objects. So right here I have a coffee container, and if you fold it, as you can see, it folds into a rectangular prism. So it has a length, width, and height, and it doesn't matter kind of how you visually see it, whether this is the bottom or that's the bottom or this is the bottom. It does not matter. So today we're going to talk about surface area, how much cardboard this is needed. Extremely important if you're an engineer at Target or General Mills or whatever, you want to package your material in the least amount of cardboard and or plastic to save money. So today we're going to talk about how to find that surface area. So if I had that rectangular prism, I'll quickly draw one for us. You don't need to be a perfect artist. I kind of draw a couple to make it look three-dimensional. And as you saw here, if you were to draw a net or visualize it as a net, you can kind of flatten it out, and you always have 6 faces. 1, 2, 3, 4, 5, and 6. There's always 6 sides to a rectangular prism or a cube. So let's say this rectangular prism had a length of 6 inches, a width of, let's say, 4 inches, and a height of 5 inches. And it doesn't, like I said, it doesn't matter which way you draw it or visualize it, it'll be the same answer. So I have 2 of everything. I have 2 6x5s. This front, as well as the back that I can't see. So I have 2 5x6s. And I need to add that to 2 4x5s, which is how I drew it, would be my sides. And my last one, I also have a top and a bottom. So I have this 6x4 as my bottom, and as well as the top. So I add 2 4x6s to get up how much space on each. So this is 2 times 30 plus 2 times 20 plus 2 times 24. So I have 60 plus 40 plus 48, which gives me 100 plus 48, which gives me 148 inches squared, because we're talking about surface area or a two-dimensional, because we're just referring to the two-dimensional faces, not how much stuff goes inside. That's going to be in a few days. So that would be how you find surface area to a three-dimensional rectangular prism. We'll also do triangular prisms and cylinders. Finding the surface area for this one, we're going to go straight forward, is something like this. You also, if you are visually inclined, you could also see this let's say I draw that again. And I had a 6x4x5. You could draw, if you could visualize it, the net. That might help you. So let's say this is my my 6x5. So this is 5x6. And attached to this 5x6 is my bottom, which is a 6x4. And attached to the bottom is my back one, which is another 6x5. Which is attached to the top, which is my other 6x4. Now I have my 2 sides of 5x4, which has to go to one of the 5s. So my 5s are here and here, so I can put it here. So this would be a 5x4. And my other one back here are also by 5x4. And then you could just visualize that or draw it, and you could find the area of each face. So 20 30, 20. Once again, I'm just multiplying the length and the height. 4 times 5, 5 times 6, 24, 30, and 24. And I add those all up, and I still get my answer. That would be 60, 100, 148 inches squared. So once again, just a refresher on surface area of three-dimensional objects. Today we talked about the rectangular prism, very similar to a triangular prism and so forth and so on. We'll cover that at a later date. Have a great day.